Okay, so I'm hoping this will work. I'm at home, so I'm going to try to go ahead and do this at home with my computer, so we'll see how this goes. So this was something we did today. We went over this quiz to review for the post-quiz you'll have tomorrow. You saw the pre-quiz last week, early last week. We've been reviewing all this, so we're going to do the post-quiz now. So let's just look at this. We have write the correct information in the following questions. So atomic mass for sodium. So I'm going to come over here, and we see it's sodium right here. And my mass is always going to be this number on bottom. It's the imperfect number. Like, think, how many times does somebody have a perfect mass of 1, 2, 3, 4? No, it's normally like, 150 pounds and 8 ounces or something like that. Very rarely are we perfect. So sodium, all these elements are the same way. So sodium's mass is 22.990. We can round that. So a good answer for this one would just be 23. Let's see here. We'll do this. Well, like I'm wanting to do a text box. I don't know what it's doing. Anyway, there it is, 23. Okay, so that would be a good answer for that. You can round up, that's fine. So let's look then, atomic number for aluminum. If I find aluminum right here, the atomic number is the top number. So we'll see that aluminum is 13. Alright, so let's look at number of protons in potassium. Alright, so potassium is right here. Now, the way we find protons always is my atomic number. So number of protons is 19. That will never change. This number, if it changes, if number of protons change, like to 20, you are no longer potassium, you are calcium. So proton number stays the same. It never changes. It's always that atomic number. So for this one, it is 19. Number of electrons in potassium. Well, if we are not an ion and we are neutral, if I have 19 positive protons, then I will have 19 negative electrons. So we're going to assume that this is neutral unless I tell you otherwise, and say that it is 19 also. Now remember, where am I going? Remember that that's only a neutral atom, so this will always have 19 protons. But remember, potassium sometimes can be a +1, which means that it lost a negative electron. So there are times when potassium really only has 18 electrons. But for tomorrow and for the quiz, for that purpose, we're going to assume that these are neutral atoms, and there's 19 positive protons and 19 negative electrons. All right, let's look at the number of neutrons in potassium. This is one kids tend to get wrong. So this mass number right here, I get my mass from my protons and my neutrons. Electrons are so small, they weigh like 0.000000005 AMUs, atomic mass units. So it's so small, they're hardly, like, we act like it doesn't even have a weight. But my protons and neutrons are both 1 AMU, 1 atomic mass unit. So I know that potassium is 39, the mass is 39. I know that 19 of that 39 is coming from protons, right? So I'm just going to subtract 39 from 19, and that is going to give me my neutrons. So 39 minus 19, and that will give me 20 neutrons. Number 7, the electrical charge of sodium. So on your periodic tables, I had you guys write charges down. A +1 here, +2 here, +3, skip carbon, -3 above nitrogen, -2, and then -1 above fluorine. So sodium is going to have a +1 charge. I'm looking for the electrical charge of phosphorus. I'm sorry. Phosphorus is right here. It will have a -3 charge, which just means that it will want to pick up 3 negative electrons. Now we're going to do the electrical charge of sodium. Sodium is in this first column, which means it is a +1, which means that it lost a negative electron to be a +1. All right, number 8. How many valence electrons does strontium have? Well, let's go over here and find strontium. It's right here. Remember, I had you guys number 1, 2, above boron 3, 4, 5, 6, 7, 8 valence electrons. That's how many electrons are in the outer shell of each element. So for we wanting, what was it? Strontium. So strontium would have 2 valence electrons. How many valence electrons does neon have? So let's look over here at neon. Oh, won't let me go. There it is. All right, neon is on the very end, so it's going to have 8 valence electrons. Okay, number 10, are boron and aluminum in the same family or the same period? So let's find boron and aluminum right here. That is a group or family. Those names are interchangeable. So if it's up and down a column, it is called a family or a group. Periods go across. And if you notice on my big periodic table in the classroom, there's actually red numbers that go down the side here, and it actually says period 1, 2, 3. Okay, so these are in the same family, or sometimes they call them groups. All right, number 11, is selenium a metal or a nonmetal? Well, on my periodic table in the classroom, and I told you guys you could do it too, there's a zigzag line that runs right along here. And selenium is on this side. And if you're not for sure if that side is metal or nonmetal, just look here. Oxygen, helium, these are gases. So this tells me this is my nonmetal side. So selenium is going to be a nonmetal. Number 12, is cadmium a metal or a nonmetal? If you look at CD here, it is on this side of the zigzag, and these are all my metals. All right. Number 13, if I have 1 atom of aluminum, how many atoms of fluorine would bond with it? So here's what I'm going to do. I've got aluminum right here, which is a metal. I have fluorine over here, which is a nonmetal. So that is ionic bonding, right? So aluminum is a +3. Fluorine is a -1. So how many fluorines would I need? Well, I would need 3 fluorines, right? If aluminum is a +3, I need 3 negative fluorines to get those charges to cancel out. So my answer to this is 3. And if you were doing that formula for this, it would be AlF3. I'm sorry, I'm sure I could figure, oh, there. I can do subscript. AlF3. Okay, number 14. If I have an atom with a +3 charge, or electrons lost or gained. Well, if it's +3, they lost 3 negative electrons to give it that +3. So, for example, we just saw that with aluminum. Boron is a +3. It means it lost 3 negative electrons. Number 15. How many neutrons does hydrogen have? Well, remember up here when I talked about neutrons? Protons plus neutrons give me my mass number. I have 1 proton, and my mass is 1, which means I have 0 neutrons. Remember I just told you on potassium, take 39 minus 19? Well, here I would take 1 minus 1, and it is 0, and that really throws kids off sometimes because they don't think that that is possible, and it is possible to have 0 neutrons. All right, let's look at the short answer. What 2 of the 3 subatomic particles can change in number? Now, usually when kids hear subatomic particles, their brains shut down and they're like, I don't know what a subatomic particle is. Well, think of 3 particles we talk about. We talk about protons, we talk about electrons, and we talk about neutrons. Those are my 3 subatomic particles. Okay? Now, what 2 can change in number? Well, 1 that definitely changes are electrons. We talk about giving and taking and sharing electrons all the time. So this can change. Now, protons cannot change, right? Hydrogen has 1 proton. If all of a sudden I have 2 protons, I become helium. Okay, so protons cannot change. Cannot change, which means that my neutrons can, and my neutrons can change. We see that in radioactive elements. We can get something called, instead of carbon 12, we can have carbon 14. That means it has 2 extra neutrons. It has a weight of 14. We know my protons are never changing. So if I have carbon 14, I gained 2 neutrons. It says, why can it not change? So why protons cannot change is because it would change the element. We cannot do that. It's just not possible. If we could do it, people would be doing it. Because think about that. If I had mercury, for instance, has 80 protons. Let's say I could take a proton away and change that proton number to 79. I now have gold. People would be changing stuff to make gold all the time, and it's just not possible. We cannot do it. People have tried without much success. All right, let's look at 17. Carbon does not have a charge. This is because it covalently bonds, right? When I am covalent bonding, it's two nonmetals. I am sharing electrons, not giving and taking. The only time you get a charge is when you give and take electrons. So what does it mean to covalently bond? It means to share electrons. Now remember, we have two nonmetals, and that's how we get those covalent bonds. All right, 18, show the formula for calcium and chlorine. Is this ionic or covalent? Well, I've got calcium over here is a metal. Chlorine over here is a nonmetal, so it is ionic. So then I'm going to look at charges. Calcium is a +2. Chlorine is a -1. So let me just write that right here. Calcium is a +2. And chlorine is a -1. Alright, so when I talk about crisscrossing these charges, that 2 is going to go to the calcium and that 1 is going to go to the chlorine. 2 is going to go to the chlorine, that 1 is going to go to the calcium. So this would be CaCl2, and my charges would then equal 0. Number 19, show the formula for sulfur dioxide. Is this ionic or covalent? Well, as soon as I see that prefix, dioxide, I know it's covalent. All my covalent bonds have prefixes like that. But you could check, and there's sulfur and there's oxygen. They are both two nonmetals, so it is covalent. So now this is saying, show the formula for sulfur dioxide. Well, it's SO2. Sulfur, if it doesn't have a prefix, so I'm assuming it's just one, and dioxide means two oxygens. Now, if you were to do the dot structure for this, all right, because that's what we have to do in covalent. It's a little bit more tedious figuring out covalent. I need to find valence electrons. Okay? Ooh. Well, here we go. So sulfur, let's look that up. Sulfur right here has 6 valence electrons, but so does oxygen. So I've got 6 from sulfur and 6 from each oxygen. So that's really 6 plus 12, which is 18. I have 18 dots that I can play with. All right, so I'm going to try to draw. Bear with me because I don't know how this is going to go. So what I'm going to do is I'm going to draw my sulfur. Oh gosh, do not laugh at my drawings. I'm going to attach my 2 oxygens. I'm doing this with just my mouse pad here on my laptop. Whew. Alright, so I've got 2, 4, and I can play with 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. So then I asked the kids, I was like, okay, does everything look okay? And right away they were like, nope, sulfur only has 6, it does not have 18. I said, okay, what do we do when one's not happy? Well, one is not happy, we take from a happy, and you don't take and give, you don't take and put it over here, you have to share. Okay, if I took and just gave it to sulfur underneath it, then this oxygen wouldn't be happy. So now we have a double bond. Alright. Number 20, I talked about this with the class at the beginning because we looked at the graphs that they did, where you guys did the graphs with the different color highlighters. And I was like, there's a really easy way to look at this. I had them circle helium on their periodic table, and I had them write high ion E. That means high ionization energy. That means how much energy do you need to get an electron from these elements? And you need the most energy to get an electron on helium. So as you go up a column and as you go across to helium, you need more and more energy to get an electron. The reason that is because it seems crazy. It seems like, okay, why up here? Well, first off, as you get closer and closer to your 8 valence electrons, your noble gases who are stable, you don't want to lose electrons. Think of lithium. Lithium, it wants to lose one. That's why it's a +1. It's like take an electron, but it does take some energy to do that. But you get to fluorine, it wants to gain an electron. It doesn't want to lose any electrons, so it takes a lot of energy to get it to lose an electron. Same with neon and helium and all of these. They don't even want to gain or lose. So it's going to take a lot of energy to get them to lose. Whereas francium right here is going to be the easiest one to get one to lose from. Not only is it a +1 and it wants to lose an electron, but as you go down periods, you get more and more orbitals of electrons, and they get further and further away from the middle of the atom, the nucleus, and it's easier to lose one out there. So that's what's happening. Now, the second thing that I had them do on their periodic table today was I had them circle francium, and I had them write biggest radius. Francium is my biggest element on here. Okay, so as I go down, that makes sense, right? Like as I go down, look at this. I'm increasing my atomic number. I'm increasing my weight. So yeah, francium is going to be bigger than cesium, rubidium, potassium. But it is a little weird when you think that, well, shouldn't like OG, shouldn't that be bigger than FR? Well, here's what happens. As you go across and you get these electrons and you get a full outer shell, it's like they're really stable and they're really happy. So it's almost like they hug in on each other a little bit. So they tighten in on that nucleus and it makes them just slightly smaller. I'm not talking like anything crazy, but they are just slightly smaller because of that. Francium doesn't have that. It doesn't have this close, stable outside I can't think of the word and I just used it. Orbital. It doesn't have this nice stable orbital. So your electron kind of floats out there a little bit more. So it makes it slightly larger. So francium is your biggest. So here you could do a couple things here. You could say as you go up a column or a family or a group, whatever you want to say, as you go up a column, ion energy gets larger. You could say that. You could say as you go down, it gets smaller. You could say as you go right across a period, across the periodic table, ion energy increases. You could say something about the radius. You could say as you go down a column, the larger the radius gets. You could say as you go to the left of a period, the larger the radius. Okay, you could say any one of those. There's 4 different ones that talk about trends. This extra credit we can only do if we had a normal non-COVID year. Like last year, we did not get through everything, so we never talked about sublevels. So it makes this a little bit difficult to do. So I will show you how I help the kids figure it out. It says I would need 2 sodiums to make me happy. So if you need 2 sodiums, that's a +1 and a +1. That must mean you are a -2. So I'm in this column here. Then it says I am a gas. Alright, well, I've got some metals in here. Look, metal. There's some metalloids that go along this stair step. They're called metalloids. So it really leaves me with sulfur or oxygen. Well, if you knew what the 2p sublevel was, which you don't, we will eventually get there. We didn't get through everything last year. It would be oxygen. So your answer would be oxygen there. Once again, this is not going to be on your post-test. You guys already took the pre-test, so you've seen it once. You kind of know what it looks like. Last thing I want to talk about is when you do have these ions, this electrical charge, it is called an ion. That was on the test. Some of you guys got it right, but make sure you know it's called an ion. It's no longer just an element or an atom. It's an ion. I think that is it. If you have any questions, let me know, and hopefully I will see you soon. Bye.